Okay, our very last sections, 4.8, then we are done for the whole semester lectures. Okay, let me try. Okay. Now here you see we are going to talk about two new functions. Actually, overall, our chapter 4 is talking about the trigonometric function. So like a sine theta, y equals to sine theta, or y equals to cosine theta. Now the input is angles. But right now, 4.8, we want to talk about the applications. What type of application? For example, when we are talking about a spring, so the displacement of the spring, displacement of the spring. So we try to use the model of the sine cosine function, but the input may not be the angle anymore. So we use the concept of the angle to develop the concept of the sine cosine trigonometric function. But right now, after we are all settled down, we understand how to deal with all the formulas. Then we may use these formulas, and then our input, for example, if we say pi over 6, input pi over 6, for example, like this. Pi over 6, we assume is a angle, radian. But right now, we may say pi over 6 is hour, or second, or whatever the things you want to use the unit. Anyway, whenever you input a number and follow the function, there will be an output. And if any model on the real life satisfy this model, or I say this model satisfies some real life situations, then we can use this model to estimate or calculate the result for our real life examples. Okay, so right now we are going to talk about if you have a spring, and when you stretch or shrink the spring, you can pull the string, or push the, the spring, then the end of the spring may have displacement. So displacement means if this circle goes, this end goes to here, then the distance will be d, right? If you pull to here, then you pull the distance d. So right now, if we have a model for the displacement called d equal to something, or we can choose another model. So on the real life, for example, if you have some sort of data, and you say, okay, this looks like a straight line, you may say so, right? Or if the real life data looks like that, you say, okay, this looks like a sine or cosine function, you may say so. And the real life, just we say almost the model almost satisfy the real life situation, but not exactly. But it's okay. A little bit different is okay. So let me erase those marks here first. Okay, so I think you kind of already understand. We try to use a trigonometric function to approach the real life situation. This is not too hard to understand, but many students will question about something. Say, okay, teacher, the spring displacement just up, down, right? Up, down, up, down, up, down, up, down. Never have a graph like this direction, right? It's up, down only. How come our graph is left, right? So how I answer this question? Okay. So when you push the spring up, so for example, you make it here. It's not going to be magically happen. I mean, from here to here, it take time to make this displacement happen. So like when in the original position we say 0, so no displacement. And then after 1 second is there, a little bit, 1 second. And after 2 seconds, it's there, for example, okay? And after 3 seconds, it's here. And after 4 seconds, probably is somewhere here. For example, this model is not perfect. Let me do, okay, so in the beginning, times 0, it's probably here, right? And after 1 second, it's probably here, 2 seconds, 3 seconds, 4 seconds. And on the 5 seconds, so 0, 1, 2, 3, 4, 5 is the biggest push. So when we push up to here, then stop. You cannot push anymore. And then you start to release. You release. Then the displacement become this and this and this. Okay, let me make the graph bigger. Sorry, too small, you probably cannot see. So if this is our trigonometric function, so let me say it one more time because the graph is too small. Okay. So say we try to push the spring to squeeze it to a new place. So in the beginning, I said that t equal to 0, no displacement. And when the t goes to 1 second, there's a little bit of displacement. When it goes to 2 seconds, a little bit more, 3, 4, 5, 6, 7, 8, 9, 10, probably go up to 10 seconds. You have the biggest possible displacement. What's the displacement? We call it D, right? We call it A. The biggest possible displacement, we call it A. And then we release. When we release, the displacement becomes smaller and smaller and smaller till go back to the original position. But the t maybe 20, probably, okay? Depends on what's the model. Now, if someone has observed the displacement for more than 20 seconds or more than 40 seconds, 60 seconds, now if we realize there's a model of the sine or cosine function, then we can just assume this model has the satisfied the sine cosine function. And then we try to find what's the greatest displacement, which we call amplitude. and we try to find the period when you complete one cycle. Like in my model, looks like 40 seconds is the period. Okay, so WT, it means the angle before, but right now it doesn't mean the angle right now, just the input. Just the input. And this W work as the formula B. Earlier we had the trigonometric function. Okay, and how come our graph is not up down? Because this is not a real displacement on the real life, because it involves time. So we make up down to be this way, with to indicate the time. Okay, so if you squeeze the whole graph, whole trigonometric graph squeeze together, then it will be just up down in the same position. Okay, but right now the graph involves time as the x-axis, or we say t-axis. So therefore we kind of stretched our graph and displace the whole graph become the sine function or cosine function. I hope I explained everything detailed enough. You can accept the concept. And then after you accept those concepts, then I will use the model and try to calculate according to the question ask you to answer. Okay, so roughly I erase. Okay, now when you choose sine function, when you choose cosine function, this depends on if your original original position if it's 0, then you choose sine function. If your original location is not 0, okay, then you choose cosine function or choose other model. That's all possible. So depends on what's your original position. But that's not important right now. Anyway, I think a question itself will tell you which trigonometry function we are talking about. But right now we want to focus on what's the period for the model. Now remember, the original period for sine function is 2 pi. Right? It's 2 pi. And this works as x. So the formula looks like y equals to a sine bx and plus 0. So how you find the period? The formula is 2 pi divided by b. Right now our b is w. So the period will be 2 pi divided by w. Now in the book we also talk about the frequency. So what's the frequency means? If inside one period you have 2 pi over w. Okay, one period means one cycle. So one cycle, you have one period, right? Now this period is from 0 to 2 pi over w. Now, frequency means so 0 to 2 pi w over w, this means time, right? So maybe hour, maybe second. Okay. So the amount of time you have one cycle. Now the frequency means the frequency is talking about on the 1 hour. Okay. How many cycle? So period means every one cycle you have how many, you need how many times. The times for one cycle. And the frequency is one cycle. Sorry. How many cycle in one time? In one unit time. Okay. So it's different. Period means how many times required for one cycle. And the frequency means how many cycle will happen in one unit time. So basically they are just reciprocal. So that's all I can explain. Okay. How you memorize the formula for frequency? Simply you already agree with the period of the time. And then the reciprocal is the frequency. So just upside down numerator and the denominator. Then you find the frequency. Okay. So let me erase all the mark here. Okay. Probably not erase. I would like to save all the mark here because probably you want to study later. Okay. Now, number 2, the number of the cycle per second or per hour. It means per PER means every unit. And right now we are talking about the time. Okay, so for every 1 hour or every 1 second, how many cycle we may have? Then this called frequency. So number 1 and number 2, they are just the reciprocal. So the time or the period for one cycle means period. So the time for the period, for the time for one cycle, we call it period. And the one, how to say that? The one period, okay. The unit time will have how many period? Probably half period, probably 1/3 period, probably 4 period. So that's called frequency. How frequent it happen. So how many cycle may happen in the unit time? How many times it happen means how frequent it happen. So that's why it's called frequency. Okay, next one, number 3. Okay, number 3, just the calculating question. They give you angle A is 5.8 degree. So whenever we are talking about anything on trigonometry, the best is you graph. And this question already provided the graph. Okay, so we just make sure we have opposite and adjacent. here they provide the opposite and adjacent. If you have opposite and adjacent, you can easily, oh sorry, they only provide what? A is the opposite, so they didn't provide the adjacent. Sorry about it. Okay, so this question provides only opposite. Then, if you have angle and opposite, obviously you can either talk about sine function or talk about tangent function. If you talk about sine function, then you can solve for C. This is hypotenuse. If you use tangent function, then you can solve for B because this is adjacent. So opposite over hypotenuse is sine function, and the opposite over adjacent is tangent function. So equation 1, you solve for C. Equation 2, you solve for B. And that's your job to finish the question. Number 4, same thing. The information the question provides, there's no angle here. Oh, there's no angle. But they provide, okay. So you have a 90-degree right triangle. When they ask you angle A, then you can use how you find angle A. This is angle A, right? This angle A. You can either use sine or cosine to find angle A, but angle A, you can see that you have a hypotenuse and you have a adjacent. Yes? Okay. So adjacent and hypotenuse need to be cosine. That's why I choose cosine function. And whenever you want to solve for angle A, you want to use arc cosine. Because this acute angle, you use arc cosine, you make the calculator may directly give you answer. So this is number 1 here. What's the answer? Here. You use calculator to find it. And when you want to talk about the angle B, let me change it to other color. So angle B, this one, angle B, this becomes to opposite to the angle B. And this is still hypotenuse. So that's why I use opposite over hypotenuse. I need to use a sine function. So that's one way, and then you use arc sine, or 1.22 over 9.92. Then you can find the answer of angle B. So this is angle A, right? Now, basically there's a shortcut. Once you already find out what's angle A, and you understand that this is 90 degrees. So one triangle, you have angle A, and you have 90 degrees, and the angle B will be, because angle A plus angle B need to be another 90 degrees. So you just say 90 minus angle A. Then you have angle B. So that's a shortcut. Okay. Now it goes to next question. Number 8. Number 8. Okay, this is number 6. Oh, number 5. Sorry, my eyes is kind of blurred. Number 5. Altitude means the height here. Okay, So let me bring this triangle to here. So you can see this. The angle is 13 degrees. Now the height or the altitude, we use h, but this is a hypotenuse, right? Hypotenuse. And this is adjacent. Now, the question asks you to solve for altitude. Altitude is opposite to the angle. So it's opposite to the adjacent. Then you need to use tangent. So nothing to do with the hypotenuse. So how to solve for h? You simply multiply 17 over 2, multiply 17 over 2, then you can reduce the denominator. So solve for h. Use calculator to evaluate. I forgot to print this. So this is number 5. Number 6. This is the house and this is the wall of the house. Now there's a ladder this way. So, and this is a ground. Now this question is talking about if the ladder itself is 20 feet, ask you to find the height. So this height happen to be the opposite side. And this is hypotenuse. And they provide the angle is 75 degrees. So when you have opposite to the hypotenuse, you need to use a sine function. And you multiply 20 on both sides. So reduce denominator. You have the height is 20 times sine 75 degrees. So you use calculator to evaluate the height. Number 7. Number 7, you need to read the question first before you understand the question. Let me see. So I graph for you, but you better read by yourself. Okay, so we have an airplane and some passenger from the airplane. They take a look. There's 2 tongues. 2 tongues here. That's number 1, number 2. Okay, and try to use trigonometry to calculate how far away these 2 tongues, the distance between these 2 tongues. Now, the question provided here is the angle of depression, the angle of depression. What's the angle of depression? Angle of depression means if your eyes is here, well, big eyes, and then you look down, okay, look down, then this is the angle of depression. So here, one angle of depression for first tongue is 55 degrees, and the angle of depression of the second tongue is 26 degrees. Okay. Now, this question is hard for the students. Why is it hard for the students? Let me erase those marks first. Because most of students, probably you never take a geometry before. Then this concept will be hard for you. Okay, make it a little smaller. Now, in the geometry. If you have two parallel lines, how do you know these two lines parallel? Parallel. If you have two lines and you make the third line across these two lines, this line 1 and the line 2, and form 90 degree, then we say line 1 parallel to line 2. Okay. Now, after we agree these two lines parallel, then there's another thing happen. If I have the fourth line here, so this is another line go across, then what happen? This angle will equals to this angle. They are equal angle, guaranteed. Also, I guarantee another thing. These two angles also equal. We call this alternate angles. So those things, it takes time to learn. But right now, actually, whenever you take like for me, when I as a student, I need to take a geometry before I'm allowed to take a trigonometry. So that's why the trigonometry book will assume you already learned geometry before. But right now, I kind of need to assume most of students didn't know, didn't learn geometry before. So the additional concept is here. You have to agree. If two lines parallel and you have a straight line go across, then we call this alternate angles. Congruent means equal, okay? Congruent. So those geometry, only one thing you have to agree is because you have these two lines. This line is the line when you want to have a depression from the angle. So this line need to be parallel to the ground. In other words, when you are building a triangle, this is 90 degree. When you take a look how high, when you are talking about the height, then this is 90 degree. And if these two lines parallel, then when you have a line across, so this angle need to equals to this angle. What? Then it is 51 degree. Why I make a mistake here? 19. Oh, sorry. This is 51 degree, right? 51 degree. Okay. This is 51 degree because I have here. Oh, no. It's 51. Oh, okay. Let me see. Why I say 39? Let me see. So if this is 51 degree, then here need to be 51. Sorry about it. Yeah, I was right. Sorry. So if this is 51 degree, then here need to be 51 degree, which is this one need to be 51 degree. Yes, 51. So this is 51 degree. And these two angles plus together need to be 90 degree. So this need to be 90 minus 51 degree, which is 39. So I was right earlier. Sorry about that. Now, so for this triangle, I make it here. You have this triangle here. Okay. Now let me erase all the mark here. The mark here. Now, if I talk about another triangle, this big triangle, this big triangle, what's the angle here? So this is 39 degrees, right? And then what's the angle? 51 minus 26. So this is 15 degrees. Therefore, the whole thing will be 39 plus 15. And if you have 39 plus 15, you may easily find out what's the angle here, but probably you don't need to. Okay, now after all the geometry, then you can easily find A, because A right now is the opposite of the 39, is opposite. So you use the sine function, opposite over hypotenuse. Then you solve for A. So that's one thing. Okay, let me erase the mark again, because we want to find out. So right now, this one, we call it A. We call it A here. So here we have A plus D. A plus D for the big triangle. A plus D, same thing, is the opposite of the angle. And this is, wow, did I make a mistake? This 10 is not the hypotenuse, so I made a mistake here. This 10 is adjacent, right? Adjacent. So this 10 is adjacent. If this 10 is adjacent, I need to use tangent. So I just remember last night I made a mistake on 4.7 homework. And right now I just find one more mistake on 4.8 homework. So hopefully I can remember to find the answers. Now to exchange, to change my work. Okay. Anyway, so the rest you can finish by yourself. You change it to tangent because this opposite to the. So for 39 degree. So for 39 degree, this is opposite, this is adjacent. Okay. And for the 54 degree, this is opposite. This is adjacent. So you need to use tangent. Sorry about that. Okay, and then you may finish the rest by yourself. And I'm going to end my video here and keep going pretty soon for the very last one video. So see you next time. Bye bye.